Okay, so today we start our new unit over transformations. Okay, this is something that you guys typically do pretty well at, but there is an algebra component to it that is very important because it was on the STAR test like 6 times last year, so it needs to be known. That's one of the reasons I'm doing this video, is to make sure that we're all on the same page or whatever. So, when we're talking about transformations, a transformation is a function that describes a change in the position, size, or shape of a figure. Okay, so we're going to take a shape or a point on a graph and we're going to change that point in some way. Whether it's the position of it, where it's located, the size of it, we could make that shape bigger or smaller, or the shape itself. So there are 4 types of transformations that we're going to talk about. The first is a translation. You'll remember this because of that SL. That will be the shapes that slide. They could go up 4 and right 2. They're going to slide in different directions. The shape is not going to rotate or change in any way other than its location. Then we'll look at reflections. This is when we flip over a line. Everything on that shape will look backwards in some way. Then we're going to look at rotations. Rotations are exactly what they sound like. We're going to rotate that shape. This is where we're going to have to figure out clockwise and counterclockwise, so we know what direction we're rotating, and we have to know certain degrees. Obviously 360 degrees is all the way around, right? So 180 degrees would be halfway, and so on. We'll talk about that quite a bit. And lastly, there are dilations. Exactly, I heard Cameron say it. Dilations are when we get bigger or smaller with our shape. Okay. Now today we're going to mostly be talking about translations. Alright, so the only thing you really need to know going into this lesson, the only thing that's really important to know going in is these 2 words. Image and pre-image. Okay, I probably should have drawn those other direction, but whatever. Okay, we're going to hear these terms quite a bit. The pre-image and the image. Now, I've talked about how we're going to be moving or changing a shape, right? So, obviously we're going to have the original shape, and then we're going to have our shape after the transformation. Pre-image is before the transformation. This is our original shape, our original points. That would mean image is after the transformation. Okay, so if they give us the pre-image, they're giving us the original shape, and then we'll transfer all the points however it tells us to. We have to know these words because in the STAR test, sometimes they'll say, the shape on the graph is the image after such and such. And we need to know that the translation or whatever it may be has already happened because it's the image. All right, so they may be asking us for the pre-image, which means they want us to work backwards. Okay, so we need to know those 2 terms, pre-image and image. All right, so let's talk about translations. All right, a translation is a transformation that slides a figure along a straight line. Okay, the image has the same shape and the same size as the pre-image. So we're going to end up with 2 shapes. Those shapes are going to be the exact same shape. Nothing about them is going to change. So, let me show you a quick example. Let's say I have let's say, oh, sorry. Let's say I have this triangle here. A, B, and C. Now, I want to translate it. Let's say 3 right and 4 up. So here's what we're going to do. For each point, we're going to go 3 to the right and 4 up. So for C, that's 1, 2, 3. 1, 2, 3, 4. Right here is my new C. I'm going to call it C prime. You're going to see us use a lot of these primes because it helps us to decide which came first, which came second. Which is the pre-image, which is the image. For B, 1, 2, 3, 1, 2, 3, 4. There's my B prime. And then A, 1, 2, 3, 1, 2, 3, 4. A prime. So as I connect these, okay, we have the pre-image is the blue triangle. The image is the red triangle. They're the same exact shape, right? Nothing about the shape has changed. They're also the same size. They are completely congruent. So if we're working on translations and you see that the size or the shape has changed, you know you did something wrong. Questions there? We all feel good about it? Okay. All right. Let's do some more examples here. Let's say we have okay, if we take this shape here and we want to go, let's say left 2 and down 1. Okay, I can actually just look. I don't have to draw the lines. I can, for each point, I can go left 2, down 1. Left 2, down 1. Left 2, down 1. Left 2, down 1. There we go. Super difficult, right? Like the hardest thing we've ever done?
Yeah.
Totally.
It's harder than algebras.
Okay, so let's look at this. Let's say we have triangle A, B, C, and we're going to do that up here. A, B, and C. Now, I want to go down 4, then right 10. All right. So we're going to do 2 different transformations here. The first thing we're going to do is we're going to go down 4. Okay, so I'm going to translate A down 4. That'd be 1, 2, 3, 4. So right here is my A prime, right? Now, I could do that with every point, but the other shortcut that you can use is how did B compare to A in its location? Up here.
A is above 3.
A is 3 above it. Right. So I can just go down 3. I know that I'm going to have my B there because it's going to be the same size and the same shape. Which means where's C prime going to be? 1 to the right. All right. So with a translation, you really only have to move 1 point if you can keep that in your head. If that confuses you, move all 3 points. Doesn't really matter. Okay, and then lastly, we're going to move to the right 10. So that'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, now, I can't call that A prime, because I already have an A prime, right? So this is going to be a double prime.
Coach,
Yes, sir.
how would you know, like, where to move them, like, down forward and like, kind
Well, because it asks us.
Yeah.
Oh, okay, so it's like,
Good. Alright, so we have our regular ABC, that's our pre-image. Then we have A prime, B prime, C prime, and then we have A double prime, B double prime, C double prime. Easy enough. Okay. The other thing that they can do to you with a graph. We'll stick with the triangle here. Gosh.
Coach can't go home. You can.
All right. So, which one came first?
That one there.
Which one?
The one with the one in it.
The one with the 1 in it. Good. Okay. We need to be able to recognize that based off of the primes. Okay. So, because what they can ask us is based off of this graph, what was the translation?
The one to the left is top.
Up something,
No, actually put that way.
Up like that.
and I guess left something, right?
Yes.
Okay, on the STAR test, this is going to be wrong.
Hold on, Coach, hold on. I can figure it out.
Yeah. I would rather you try to figure it out than go, up something.
Up 5. Up 5. What?
All right.
Hold on, Coach.
So here's what I would do.
left 5, up 5.
I would pick 2 corresponding points. Okay, for me, I'm going to pick B and B prime. Now, you are right. We are going to go left something and then up something, right? So, let's look. Left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
You go left 12, Coach. Yeah.
And then up. 1, 2, 3, 4.
Yeah.
So that's not too tough, right? Here's something you have to avoid, because the 8th graders make this mistake all the time. You're counting how many times it jumped, correct?
Yeah.
So that would be 1, 2, 3. We're counting how many times we've moved. I cannot tell you how many 8th graders will go 1, 2, 3, 4, and they're counting each point. Okay? This is 3, not 4. So do not count just by putting your pencil down. Count by how many times you jump. 1, 2, 3, and then you'll get the right number. That's an easy mistake to make that'll cause you to fail an assignment. All right. Now, let's talk about the big thing. This is the important part of this lesson, because just moving shapes right and up so many times, that's super easy. Okay, in fact, you guys have been doing translations since, I think, 5th grade. Whether or not you remember them, you have done them, and they're really easy. What we're looking at this year that's a little bit new is how this looks algebraically, okay, with symbols and not even looking at the graph. Okay, we need to be able to say, if I have triangle ABC, and let's say the points are 1, 4, 3, and 2, and -5 and 10, and I want to do a translation. Let's say translate 4 right and 10 down. All right. Now, obviously, you could graph these, okay, but that's not what they want us to do. They want us to just work with these coordinates without a graph, okay? In fact, most of the time, they won't even ask you for the answer. They'll ask you for which of these answer choices is doing this problem correctly, Okay, so with translation means we are going to add and subtract. We're going to add and subtract to go left and right, up and down. So, we have two different coordinates. What are these coordinates right here? X. What kind of movement does X control? Side to side, left to right. Let's think of a left to right axis. Now, as I move to the right, what happens to my numbers?
They're positive.
They're positive. What happens when I go to the left? Negative. Okay. Now, if we talk about this right here, what are these? Y's. They work up and down, right? Up is positive, down is negative. This is pretty basic information, correct? This is the information we need to know. Okay, so here's why. If I'm going to go 4 right, which coordinate is that going to affect? The X. My X works left to right. So this is going to be my X coordinate. If I'm going to go up 4, okay, that means I'm going to the right. That's going to be adding 4, right? So I need to do X plus 4. What if it was left? X minus 4, okay? Now we got 10 down. That's going to be my Y. This is my Y, because Y is up and down. If I'm 10 down, what am I going to be doing? Minus 10, because as I go down, that's subtraction. If it was 10 up, I would add 10. Okay, so now, for each of my x's, okay, here's my pre-image. Now we're going to do our image. So for each one of my x coordinates, I'm going to add 4. So this would be 5, 7, and negative 1. Now to go down 10, I'm going to subtract 10 from all of my y's. So 4 minus 10 is negative 6. 2 minus 10 is negative 8. 10 minus 10 is 0. Okay. So these would be my new coordinates after moving 4 right and 10 down. All right. Let me show you how this is done as far as star tests, what we see a lot. Okay, let's say we have
Wait, Coach, would they put it into if on the STAR test, would they put it into a fraction, like what they wanted you to do with the numbers? Like if like how earlier this year we were taking the. Do you know what I'm talking about though? Where we would take the numbers and instead of saying on a graph we go up this much and go across this much, they
talking about slope?
Yeah, would they put it into a slope?
No, just slope is a constant rate.
Okay.
All right. So the way we represent algebraically, they'll say which one of these answer choices represents a translation of, let's see, Seabass, left or right?
Right.
Right. All right, up or down?
Up.
Okay. But how far right?
A.
Coleman, how much up?
Oh, Coach, I wasn't looking.
I'm asking you, just a random number.
7.
Okay. All right, so if we wanted to write this algebraically, what am I going to do to x?
Multiply.
You're gonna add 8. Move it to the right.
We're going to the right, which means what are we doing to 8?
Adding it.
We're adding it, so that would be x plus 8. And what am I doing to y? Up 7, which means plus 7. Good. Last thing that we could see. What type of transformation is happening here?
Translation.
This is a translation. It's the only thing we're talking about today. So what type of translation is happening? What are we doing?
All the
What type of translation is this doing? Guys, I'm recording and we will record for 10 minutes of silence if you don't answer the question. What type of translation is happening right here?
Oh, it's, what's the one where it changes shape?
No, it's translation.
Oh,
It's a translation. We've already said that. How are we translating?
to the left.
Oh,
And add
okay.
up 20.
Thank you. Left
oh, that, I thought-
3,
what type of
up
translation?
20. What?
No, I thought you meant what type of translation. I thought there was only one type of translation.
Yeah, there is only one type of translation.
Okay, so I was.
How did we do it?
Okay.
Okay, what type of translation happened here?
Nothing on X, and then Y down
Down 13.
Down 13. Good. Okay. And then let's see, we have
Right, 42.
and up 3. 37.
this would be right 42 and up 37. Good. Those are all the algebraic representations of a translation. Now, in our future lessons, we're going to talk about the algebraic representations of reflections, rotations, and dilations. I'll also make videos of those as well. This is important. It shouldn't be too hard. Okay, but here's the problem with transformations. They are initially so easy that you guys stop paying attention. You stop listening, you start thinking, well, this is easy, and you start daydreaming and talking and carrying on. And suddenly we start adding little things, and you're not paying attention. And suddenly you get lost. Okay? This is a very important part of our STAR test preparation. They ask a lot of these questions. Okay, I'm telling you, I still think the Pythagorean theorem is the most important thing we do this year, as far as STAR test is concerned. This is a close second. Okay, in fact, I would say this caused more people to fail their first attempt than the Pythagorean theorem stuff. Okay, so this is important. Don't blow it off.